Welcome back. In this video, we're going to try to solve this equation 16 minus x squared plus 9 minus x squared is 5. I have taken this one from a channel called Black and Red Pen. He presented a solution based on the Pythagorean theorem. Okay, here we're going to see that we can find many different solutions, and we're going to see that they are equivalent and they are the same exactly. I'll add the link in the description so you can go and see the solution based on the Pythagorean theorem. Here I'm going to use some shifting to find the solution. Here I can note that before I do anything, I can see that to solve this one by just squaring both sides, we will get into an equation of a fourth degree, okay, which will complicate the matters, okay. And there are many different ways to solve this one here. So we can see that this is the addition of two half circles, and each one having a center 0, 0 and radius 4 and 3 respectively. And for me, I will present a different solution based on shifting and changing the variable. Here we can write the square root of 16 minus x squared as 9 minus x squared plus 7. Okay, here in this first part. So if I let y to be 9 minus x squared, okay, and here I have to have y bigger than 0 because this is inside the square. So therefore I can transform my equation into 7 plus y plus the square root of y is 5. Okay, if I take the this one here, the square root to this side, I can square. So here I can square now. So I can square to get 7 plus y is 25 minus 10, the square root of y plus y. And therefore I can cancel the y here, and I can get this 7 here. So I have 18 minus 10, the square root of y is 0. Okay, and now we can solve for y. I can simplify one more time because I can do 9 minus 5 square root of y is 0. I can simplify by dividing this one by 2. So now I can solve for the square root of y, which is going to be 9 over 5. So I square, okay, so this is positive, I square 81 over 25. But I know that y is what? It's 9 minus x squared. So it's going to be 81 over 25. And solving for x squared, I'm going to get 81 over 25 minus 9. So if I multiply by a minus, I'm going to get x squared is 25 times 9 minus 81 over 25. Okay, here this is 144 over 25. Okay, and therefore x is going to be plus minus 12 over 5. And this is the solution. So before I do this one here, so this is 12 over 5 is 2.4. So x is 2.4 or x is minus 2.4. Okay, so one key idea left here, I need to check if these are solutions, and I think they are. I need to check the domain of definition here. Okay, so the domain of solutions. So I need to have, in this case, I need to have two conditions. I need to have 16 minus x squared bigger than 0 and 9 minus x squared bigger than 0. This first one will give me x squared less or equal than 16, and the second one less than 9. And therefore this means that x squared is less than 9. That means x is less than 3, the absolute value. That means x is between minus 3 and 3. And since these two guys, so x is 2.4 and minus 2.4, they are in this domain here, and they satisfy the equation. So the solutions are 2.4 and minus 2.4. So this way of shifting is quicker than trying to square, taking this one to this side and squaring, or vice versa. This will make the computations longer. So I have a link based on the fact that we can call this right triangle here. If this is x, this is 4, then this is just square root of 16 minus x squared. If we extend this one here and call this length of the hypotenuse 3, then this is just 9 minus x squared. Okay, so these two, if I add them, I have the square root of 16 minus x squared plus the square root of 9 minus x squared. I wanted this to be 5. Okay, so here I have similar triangles, so I can find the area of this triangle as 4 times 3 over 2, which is the same as the height times the basis over 2. So the height is x, and the basis is 16 minus x squared, the square root of 16 minus x squared plus the square root of 9 minus x squared. But I know that's 5, so times 5 over 2. Now if I try to solve, I get x is 5x is 12. That means x is 12 over 5. I get one solution, but I see that my function is even, and I get the other one. Okay, so this is I'll post the link for this one if you want to see more. So this is algebra based, this is geometry based. Thank you.